This is on inverse trigonometric ratios, a geometry lesson. First, let's talk about why they're inverse. Back when dirt was young and so was I, we didn't really talk much about inverse ratios. We just did it. We'd do our trig with tables like this one, and frankly, for most of the stuff you're doing, the table's just easier. There's one in class, and you can pick it up and use it if you want. But I do want you to know how to do it on the calculators as well. So, for example, if I know the degree measure, I know that, say, if I know the degree measure is 16 degrees, and I have the adjacent and the hypotenuse, I can use 6313 as the trig ratio, the cosine ratio, to be able to find out a side length. It'd be like making a proportion like we've just done. But what if I don't know the angle, but I do know the side lengths? So I can create the ratio, but I don't know what ratio it goes with. So say it's the 16. I make myself a triangle, or I'm dealing with something that has to do with a triangle, and it's this 6316, and I find out that the ratio of the adjacent to the hypotenuse is 0.6316. All I do is I look and I say, oh, it's cosine, and it's 63.13, it's at 0.6313. Oh, look, I must have had a 16-degree angle. And that's all we did, because you really don't need another name for it, but we had it, and you can work it out without even using it. However, then we had the intervention of the calculator. Once we have a calculator, it needed to have a name, because calculators are, you know, dumb. They can't do stuff. They don't do stuff backwards. So we have inverse relations here. Inverse in this case just means doing it backwards. It's not like a reciprocal or something like that. You're just doing it backwards. Inverse means backwards. So we look here, for example, with cosine, written in blue paint above it, is cosine -1. That's what we call the inverse, or the arc cosine. So to do that, you'll hit the second blue shift key and then hit cosine. That's what you use if you know the side lengths and you need the angle. We'll have some examples on that. First off, let me tell you what the inverse trig ratios are. They're very much what you would expect. They're just the backwards of the ones that we just had. And this triangle is labeled and colored exactly the same way as the ones in the previous session. And what we have here, we call it the arc tangent, the arc sine, the arc cosine. On the calculator, it's written with a -1 to indicate that it's backwards, or inverse. So if you have the side lengths, you can get the angle. If you have the side lengths, opposite and hypotenuse, you can get the angle. If you have the side lengths, you can use arc cosine if you have the adjacent and the hypotenuse, and that will give you the angle. You work them backwards. To solve a triangle is to find everything there that's not listed. How would you do this one? Well, we have a 65-degree angle. It has it's complementary to the angle at N. Subtract from 90. That'll give you this angle. You already know that that one's 90. How are you going to find this side length? Well, you look at what you have, NP. You want to know NP, you have QP. Relative to, if I'm doing the 65, you could do it with the 25, and that would be just fine. But relative to the 65, 10 is adjacent, and NP, unknown, is opposite. So opposite and adjacent is tangent. You would say the tangent of 65 is opposite over adjacent. You would solve it just like in the previous lesson. You want to know the hypotenuse, QN, relative to the, you can do it relative to either angle, the 65 or the 25, doesn't matter. Relative to the 65, 10 is adjacent, and this is the hypotenuse. So adjacent and hypotenuse is cosine. So you would want the cosine of angle 65 is 10 over the hypotenuse. You would solve it, and then you would have solved the triangle which means you would know everything that's on it. An example for us. Here we have, there it is. In order to unload clay easily, the dump truck, the body of a dump truck must be elevated to at least 55 degrees. If the body of the dump truck is 14 feet long and has been raised 10 feet, will the clay fall out easily? Well, now that's important. So here I've drawn one here, which is the example of what we're doing. This is a handy dandy, fine looking truck driver here. Okay. And I've drawn what we're given, that it's 14 long, which in this case is the hypotenuse of the triangle under the where the clay goes in it. And then it's raised up 10 feet. Okay, so what I want to know is if it's 55 degrees. And you're saying to yourself, Self, why do I care if it's 55 degrees? Well, let me tell you why you care if it's 55 degrees. Because if you're a landscape person, or if something about your business, or whatever, you haul dirt and clay, when you raise up the dump truck, you want it to fall out. If it doesn't fall out, if it's not a big enough angle, then one of your workers has got to climb up here at this incline, which is a pretty steep incline, with a shovel and shovel it out. Chances are he or she's going to get hurt, fall down, get hurt. No, bad, bad, bad. Or, even if they don't get hurt, you've got to pay them to do that, which means it takes your delivery longer, which means you can do less deliveries, which means you make less money. So, is it important if that goes to 55 degrees? Yeah, it is. So, say you go to the Ford dealership, you need a new truck. Hi, Ford guy, I need a new truck. They say, well, we got this great one here. It's wonderful. It'll raise up 10 feet. That's enough to take care of anything I know of. And you say to yourself, Self, I know it's got to be 55 degrees or the stuff I want to unload won't unload. I wonder how I could figure out if it's going to unload when it should. You say, oh yes, trigonometry. Math rules the world. You look at it and you say, okay, well I know a 55 degree angle. I know 10, which is opposite my 55 degree angle, and I know the hypotenuse of 14. So I know the side lengths. I need the angle measure. That's arc sine, arc backwards sine, if you're using a table. So the arc sine of 10 over 14, figure it out from your table or in your calculator, and you'll find out that it's only 45 degrees. This truck, dump truck, only raises to 45 degrees. Your product, your dirt, your clay, whatever you're doing, the clay in this case, they all are different, won't fall out. It's going to cost you money. So if the truck's a little cheaper, it's not worth it, because it's going to cost you money and it's going to cost people's safety in trying to work in these conditions, so you don't want to do it. So that's an example of how you can use the inverse trig ratios. Again, if you have the side lengths and you need the angle, that's inverse, or arc sine, arc tangent, arc cosine. If you have the angle and you need the ratio for the side lengths, then you use sine, cosine, and tangent. And here endeth the lesson.